Methods of heating or boilers. The key objectives for this part of the session, I want you all to be able to state which heat sources might use fossil fuels and which might use renewable methods. Explain the key differences between combi boilers, system boilers and traditional boilers, and also to be able to describe the heat pump cycle. So there's different methods of heating hot water or heating hot water for the delivery to the taps, but also heating water to be circulated around the heating systems. Most of the methods that we're going to look at would use fossil fuels, for example natural gas, which would be also described as methane, liquefied petroleum gas, which is any mixture of propane or butane or some other sort of similar gases which have got similar properties, like MAP, but propane and butane are the two key ones that we need to be aware of. Or oil, which would use kerosene as a fuel, oil-fired boilers. And very, very occasionally you might come across coal-fired boilers or room heaters. So firstly, we're going to look at flue types. All of these fuels will require the removal of the gases from the products of combustion. And there's different types of flues. They can be described as open flued or room sealed. Open flued appliances, for example, sort of gas cookers and open fires, they actually take air from the room they're situated in. And you can see an example here. You can see this is an open fluid appliance here. The air for the combustion process is coming from the room where it's in, and in this case, it's going through, the combustion gases are going through a flue to the outside air. Flues is kind of another name for a chimney, I suppose. Room sealed appliances draw air for the combustion from an external source, and they'll also remove the products of combustion to an external source. Quite often you'll see flues with two tubes, one tube on the inside, which the flue gases will escape from, and one tube on the outside, which will draw fresh air in for the combustion process. Almost all of our modern boilers will be room sealed. Gas boilers use natural gas, methane, which would normally be supplied from the national grid, which is supplied through gas pipes, which will be buried in the ground away yellow, normally MDPE. It's the cheapest method of heating your home at the moment, though you might sometimes come across LPG boilers, more so generally speaking in rural areas. LPG stands for liquefied petroleum gas. LPG is any mixture of propane, butane or MAP, methyl acetylene, propane, if you're interested. It can be fairly expensive compared to oil boilers and compared to natural gas as well. So we're going to look at oil boilers now. Two main types of oil boilers, pressure jet and vaporizing. They both burn kerosene. The difference is a pressure jet boiler forces the fuel through a nozzle, which causes the droplets to be spread out into tiny droplets, which means that they'll ignite more easily than the kerosene would at normal temperatures. Vaporizing boilers aren't fitted anymore. They would heat the fuel first, and as the fuel is heated, it starts to give off a vapour, and then that vapour would then be burnt. So condensing boilers, modern boilers, all modern sort of boilers that we're looking at the moment are going to be condensing boilers, and what that means is that the old type of boiler, the traditional boiler, you would have your heat source, your gas, your burner, whatever it is, which would heat up the heat exchanger. The water would flow over the heat exchanger, through the heat exchanger, and come out the other side hot. and the flue gases would then go out of the flue. They'd still go out at a really quite a high temperature, so there was a lot of wasted energy. These sort of older boilers were probably 70-75% efficient at their best, really. And we've got these modern condensing boilers, which are all kind of sort of 88, 90, 92% efficient. So it's quite a significant increase in efficiency. And the key difference is that as the water the water goes through two heat exchangers, and the flue gases are diverted over a secondary heat exchanger as well to take more of that heat out of the flue gases. This can cause the products of combustion to condense. You know, whenever you burn any fossil fuels, you can have carbon in there, you can have hydrogen in there, and obviously it reacts with the oxygen as part of the combustion process, and that hydrogen and oxygen react together to create H2O, which we all know is water, and that water will start to condense as the temperature drops in the flue gases, as more of that energy is taken out of the flue gases, and that's why it's known as a condensing boiler, because it takes so much energy out of the flue gases that the water starts to condense inside the boiler, which means that we need some means of removing that water, and we'd use a condense pipe, normally a sort of 21.5mm plastic drain pipe, to remove that the condensed water from the combustion process. There's a video here, quite a good video, shows differences between Combi's regular boiler system boilers. You can see that in the PowerPoint, which is on Moodle, but I'm going to quickly chat through them myself here. So a traditional boiler, it can be open vented or sealed depending on what the manufacturers are telling you. You know, some of them can be, some of them can't be, you know, so you need to make sure you read the manufacturer's information before installing anything, really. But in a traditional boiler, you'd have, it would go off and it would feed the heating system with heated water, and it would also circulate through the coil of a hot water cylinder in return to be reheated. The key thing to know about a traditional boiler is that everything is going to be fitted externally of the boiler. The boiler is just there to heat the water and heat the water only. You'd have your pumps and expansion vessels if it was a sealed system type, or your pump and other appropriate kind of means of allowing for expansion separately from the boiler itself. System boilers have all of these things built into them, and they would be used for sealed systems only. We're going to have expansion vessel fitted in there, we're going to have expansion valve, pressure gauges, pressure relief valves, and the pump all built into one unit. You can see an example of that here. So you've got your expansion vessel in here, you've got your temperature pressure relief valve here, a film lip there to fill up the heating side, because it's a sealed system. Combi boiler again would be a sealed system. The heating side would be filled through a film lip. Again, you can have the pump and the expansion vessel all fitted inside one unit. But the key difference with the combination boiler and the systems boiler is the combination boiler heats the hot water inside the boiler itself, the hot water that's going to be delivered to the taps, whereas the systems boiler is like the traditional boiler in the fact that it would have a separate hot water cylinder which the water would be heated in. Alrighty, look very briefly at solid fuel. Coal is very, very rarely used. You might come across it in very old houses or in rural areas. These would be described as back boilers. You need to be very careful. If you remove a back boiler, you shouldn't seal it up. because what can happen is that actually if people put then a fire in their open fire, and you've got a little bit of residual water left in the back boiler, and it's all sealed up, that water will heat up, it'll expand, it'll turn to steam. When water turns to steam, it expands 1,600 times, which is a huge amount, and it can cause issues like you can see in this bottom picture down here. This is someone left the back boiler in, they and just sort of sealed it up. They put a fire on, and it blew up and destroyed the living room. Thankfully, when they weren't in it, you know. But it can be, buddy, not right now, Paul. Okay. We also need to be aware of another solid fuel. We also need to be aware of another solid fuel boiler. In this case, it's the biomass boiler, and this is actually considered a renewable heat source. Obviously, coal is a fossil fuel, a non-renewable heat source, but wood is renewable. It will grow in our own lifetime. So it's considered renewable, it's considered a carbon neutral heat source. And again, excuse me, it can be used in rural areas. So we're going to look at a few other renewable methods, as well as the biomass boilers. We should be aware of heat pumps and solar thermal systems. Solar thermals mainly for the heat and the hot water. But even if we did use them for heating hot water cylinder, we'd need another heat source to take that water temperature up to the 60 degrees minimum that we should have that our hot water stored at. Okay, solar thermal, look very briefly at this. Again, we looked at it in the hot water module. They can actually absorb a significant amount of heat on a good day, but they will need, particularly in the winter, another heat source connected, and it's sometimes called an auxiliary heat source, to bump that temperature up to that 60 degrees. It needs to be stored at 60 degrees for at least 1 hour a day. Heat pumps we're going to look at now. There's three main types of heat pumps: ground source, air source and water source. This literally just refers to where they are obtaining the heat from. Essentially, a ground source heat pump obtains the heat from the ground, air source from the air, water source from water, for example, a lake or a river. They all use the same principle. They take heat from the heat source, and this doesn't need to be particularly warm. You know, I mean, it could be sort of 4, 5, 6 degrees Celsius, and it takes this heat and it puts it over a heat exchanger, and inside this heat exchanger there will be a refrigerant gas. This is a gas which will evaporate at very low temperatures. So this gas will then evaporate as it absorbs the heat from the heat source, whichever source it might be. So this gas evaporates, and then it goes through a compressor, and that compressor squeezes the gas, which causes it to release its heat, turns it back to a liquid. So what you can do is you can take a lot of low temperature heat and turn it into a small amount of high temperature heat, essentially, and that's how a heat pump works. It's pretty cool. It's like the opposite. It's the opposite way around of a fridge. I don't know if you guys have ever felt around the back of a fridge before. You can feel, if you ever do that, you'll feel that it's really quite warm, because what it's doing is it's taking that heat from inside the refrigerator and dumping it out the back, and this is essentially taking that process but using it to generate heat for the house. Again, like I said previously, the water from the heat pumps will very rarely reach 60 degrees C, which means that if it was connected to a cylinder, the cylinder would need another heat source, for example, an immersion heater installed to top up that heat to 60 degrees. But it does make it ideal for underfloor heating because it's quite low floor temperatures. And obviously we don't want our floor to get too hot, or else we'll be dancing around the kitchen, not in a good way. Okay, ground and air source heat pumps are two of the most commonly installed, and you can kind of see an example here. You see up the top here we've got an air source heat pump. The air would sort of flow through that, and there'll be heat exchangers in there. And then this bottom one here shows a ground source heat pump where the water is being absorbed from the ground. Very quickly looking at energy efficiency and insulation. It's very important, as we know, to insulate or hot water pipework and cylinders. It's also very important to make sure that we insulate our heating pipework, particularly if it runs through any unheated spaces, for example, the attic or a garage. If it does go through an attic or garage, make sure you use even thicker insulation to make sure that you offset the heat losses or reduce the risk of the pipes freezing. Okay, so now it is time for your task.